Hello everyone, welcome back to Let's Unbound. So yes, I'm back with the 12th episode of the series and yes, so this episode focuses on equivalent representation of trigonometric functions. So trigonometric functions is not just simple as sin x cos x, right? If you apply many transformation, you can square it, you can add them, like we can make complicated expressions with the trigonometric stuff, like how you make square root x square, x power 4. So like that we can do with sin x also, sin square x and such things. So now how to like when we simplify something, trigonometric expressions, how to simplify, that is what we are going to do. Not only simplification, sometimes a simpler form we will expand it. So this is all about this unit and a quick review on it, and then 3-type problem solving today. So be ready with pen and paper, and here we go for the form. So yes, as I said, so we are going to do this based on identities, transformation formulas, and yes, sometimes we'll apply the concepts which we learned earlier, unit circle, right triangles, or graphical things, right? Here we go. First one is Pythagorean identity. That is primary Pythagorean identity, and then we derive two other identities from the first one. So let's see what it is. This is the primary one. Sine square theta plus cos square theta equal to 1. And you can rearrange if you want to make sine square as subject, sine square is 1 minus cos square. If you want to make cos square as a subject, it's just 1 minus sine square. So you can rearrange them. Then secant square minus tan square is 1. Secant tan, we have a identity. Cosecant square minus cot square equal to 1. So these are the three identities. So when we solve with squaring, when you find some squared things in your functions, so you can apply this, right? For simplifying or for expanding it. Now, some difference in double angle identities. So I don't have squares, but I have sum of two things, so sine x plus y, right? This is in simpler form, but you want to expand in some way. So you can use this sine of sum, right? Which is sine A cos B plus cos A sin B. So the function will change, sine A cos B, but same sign. If you have plus here, here also plus while expanding. Then cos will take the angle A and sine will take the angle B. If it's minus, same formula, sine A cos B minus cos A sin B. And here, cos A plus B means cos same function, different sign. So cos A cos B minus next function is sin A sin B. But if you have a plus, you will put minus here. And if you have minus, cos A cos B plus sin A sin B. Then tan A plus B, you can write, it is a fraction, like a rational form. Tan A plus B means numerator tan A plus tan B divided by 1 minus tan A into tan. Numerator plus denominator minus. If you have a minus here, numerator minus, denominator will be plus. Right? So this is sine, cosine, tangent, and the sum or difference. If you find it in input, sorry, if you find inputs like sum or difference in sine, cosine, tangent, we can apply this, right? And here we go. So sum, difference, and double angle. So you have sine A plus B, right? Which is sine A, and change the function cos for B plus cos A sin B, right? You want sine 2A means what? You will put B equal to A. Wherever B comes, you will put A. So what you got sine 2A here? Sine A cos A and cos A sin A. So sine A cos A sin A, they are same. You can just add them to sine A cos A. This is the way we can derive many formula from the sum and difference. Sine 2A is 2 sine A cos A, right? And cos 2A, this is one of the main form. Cos 2A is cos square A minus sin square A. And also you can write it as cos square is, you can write cos square as 1 minus sin square A, right? 1 minus sin square A minus sin square A, which is 1 minus 2 sin square A. If you want cos double angle in sine form, you can pick this. If you want cos double angle in cos form itself, it's 2 cos square A minus 1. And tan 2A, same thing. In tan A plus B formula, you put B equal to A and you will get this. right? Tan A plus tan A will become 2 tan A, and 1 minus tan A times tan A will become tan squared A, right? So this is a review. So I'm giving you a quick idea how this formula works and how we can connect each other. Do pause the video and observe uh, the thing I said and try to connect it, right? Now, other trigonometric identities, this is cofunction identities. Sine, cosine, tangent, cotangent, secant, cosecant. So they are co-functions. They are sharing some identities. Sine theta will be equal to cos 90 minus theta. They are equal. How? Sine 30 will be equal to cos 60. So sine and cosine are big things, but they are not equal to same angle. For a supplement, it will be equal. Like when you add them equal to 90, if you get them, then you can make this relation. So similarly, you can do with tan 30 equal to cot 60. If your angle add up to 90, you can apply this. Like even you can do this tan 10 equal to cot 80. I can do this because they are co-functions and the angles that I have used are complementary angles. Right? This is what this table tells and this is how it will work. Correct? Now let's move to question solving. Solve the equation using trig identities in 0 to 2 pi. So 1 minus sine square x cos square x equal to 2. If you can see something square identities will work. And what square identity you know in terms of sine and cos. So we know this sine square x plus cos square x equal 1. Right. So in place of 1 you can put that or you can put cos square x is 1 minus sine square x. Right. So you can substitute that. In place of cos square x, you can put 1 minus sine square x. Or in place of 1 minus sine square x, you can put cos square x. So this equal to cos square x plus copy rest everything as it is. So we are trying to make them simple and single trig function when you are solving any equation. Cos square plus cos square will become 2 cos square x equal to 2. 2 cancelled. Cos square x equal 1. And when you take square root on both sides, so cos x is plus or minus square root 1, which is 1. Now I got two equations. Let's solve them. Cos x is 1 and cos x is minus 1. Simple cos function like general function. So what is x? You know this cos will start at maximum 1 and end with maximum 1. So 0 and 2 pi, it will attain 1. So 0, 2 pi. When it will become negative 1, exactly in the middle, 0 and 2 pi middle is pi. So x is pi. So the solutions are x is equal to 0, pi, 2 pi. If you write in proper order, that will be the best answer. Okay. That's it. And now question number 2. Evaluate sine 75 exactly using some identities. How can I evaluate? Sine 75 is something which I don't know, right? We only know some specific angle. So in that case, you try to express this input in terms of known angle, either as an addition or subtraction. I can write 90 minus 25, right? No, 90 minus 50. But I don't know what is 15, so that will not work. So let me write 45 plus 30, right? So this will give you, and I know 45, 30 values, right? Now let's try to express sine 45 plus 30. And sine sum of an angle formula, like your angle is the sum means. So sine A plus B will go like this. Sine A cos B plus cos A sine B. What is my A? A is 45, B is 30. So let's substitute. Sine 45 cos 30 plus cos 45 sine 30. Right? So what is sine 45? It's 1 over root 2. Right? And cos 30 is root 3 over 2. Then cos 45, it's again 1 over root 2. You see one thing, sine 45 and cos 45 are same because they are co-functions and also they add up to 90. So this thing work, right? And sine 30 is 1 by 2. So simplify. Maybe I will take, like you can conjugate this, multiply by root 2 and multiply by root 2, you will get root 2 by 2. The other way of sine 45, root 3 over 2. Plus same thing here, root 2 over 2 into 1 by 2. So it's root 6 by 4 plus root 2 by 4. And it's root 2 plus root 6 over 4, the simplified answer. This is the exact value of sine 75. Right. So that's the question number 2. And now we are moving to the last problem for today. Let h of x is 2 cos x minus pi by 4. The solutions to which of the following equations on the interval 0 to 2 pi, or the solutions to h of x is root 2. So when you create when you make an equation h of x is equal to root 2, that solution and one of the option solution will match. For the interval 0 to 2 pi, we need to find which option matches here. So let me construct an equation. H of x is equal to root 2 in the sense, what is h of x? 2 cos x minus pi by 4 equal root 2. Right? So let me take the 2 there. I will get cos x minus pi by 4 is root 2 over 2. You don't want to solve the answers. If you go like you solve the question and solve all the options and match it, it will take a lot of time. So do equivalent trigonometric technique. So this is cos x minus pi by 4, but your options have only cos and 1. Okay, let me try to express. It's a difference formula, right? So I'm writing formula here. Cos A minus B is cos A cos B. Cos means same function, then sin A sin B. If you take one function, that same thing repeat, and minus means you will put the opposite. Right? So this will become cos x cos pi by 4 plus sin x sin pi by 4 equal to root 2 over 2. What is cos pi by 4? It's root 2 over 2. What is sin pi by 4? That is also root 2 over 2. Here also root 2 over 2. So now I'm gonna take the root 2 over 2 common. So root 2 over 2, if you take common, cos x plus sin x. Here also you will get root 2 over 2. Actually, this is root 2 over 2, right? And this will get cancelled. You won't get 0, you will get 1 here, right? So that's it. We got cos x plus sin x equal 1. And that's what option C shows, right? So it is option C, right? So on all the three problems, we use different techniques. And that's the wrap for today. So here, with a bonus question, we can wind up. If cos x is 5 by 13 and x is in fourth quadrant, find the exact value of sine 2x. So you will use double angle formula. Scroll back and check the formula here. Double angle formula for this. And then use right triangle or unit circle. Those combination of work is needed here. And that's it. So do the question. And if you have any other questions, queries, doubts, suggestions, you can share it in the comment section. Let's meet in next video. Until then, keep learning, keep practicing. Thank you for joining. And you can scan the QR code given here to join Let's Learn Student Community. Keep learning, stay curious.